Hello guys, it's me Shiaz. Today in this video I'm going to show you an home automation. I'm using an MQTT protocol. So in this I'm using a NodeMCU and Raspberry Pi. They are both communication using MQTT protocol. So first I just give an introduction on MQTT protocol. So actually this MQTT protocol is a machine to machine or internet of things. It's an IoT protocol. It's a very lightweight protocol, and it was designed as an extremely lightweight. And the five terminologies we have to remember on MQTT protocol, that was subscribe, publish, and broker, client. Then fifth one is topic, and it was placed above the TCP/IP protocol. And for the main page of of the MQTT protocol, you can get documentation on this mosquito.org man page. So I'm just navigating over there, so you can see that it describes all the about the MQTT protocol. So it actually publish or subscribing messages on the based on topics. Actually the topic is the thing that differentiates the messages. So here you can see that a temperature sensor is there, and one PC is there, and mobile is there, and the MQTT broker is also there. Broker and clients, the PC and mobile will be the clients, and even temperature sensor also be a client. So the temperature sensor, it publish the current temperature value to a particular topic. Here in this picture you can see this temperature as the topic. So whoever it's sending data to the MQTT broker, whoever subscribed to that topic temperature will get the message. So the PC and the mobile, it's subscribed to temperature topic. So the MQTT broker, it's whenever it gets data from the temperature sensor, it automatically publish that data to PC and mobile. So if more devices are connected to MQTT broker, they are using same temperature as a topic, so they also will be getting the temperature value. Similarly, they can use the broker can have more topics. So just moving to the next slide. In this example, I'm using Raspberry Pi as a MQTT broker, and similarly for as a MQTT client, I'm using that ESP8266. And through these MQTT protocols, I can control Raspberry Pi GPUs over my ESP8266. Similarly, I can control ESP8266 GPU over my Raspberry Pi, or even Android, any clients. Through clients I can control. So I'm just dividing this to two part 1 and part 2. In part 1, what all things I'm doing means I'm setting a mosquito, and mosquito is one of the famous MQTT server. It's available. It's available on the cross platform. It's available in Windows, Linux, all operating systems. And I'm setting my Raspberry Pi on a mosquito MQTT server, and I'm configuring my ESP8266 in my part 1, and I'm using MicroPython firmware on ESP8266. Even if you can use a default Lua firmware if you wish. And in this case I'm using MicroPython for my ESP. And so in this case scenario, I'm setting my NodeMCU to subscribe message whatever the Raspberry Pi is sending message, so it subscribe to that message with a topic. And similarly, whatever if I made an interrupt user, whenever a user press buttons on ESP8266, so it will publish a message to the broker. So according to that message, the broker will do some functionalities. Similarly, the broker is sending some message to ESP8266. According to the message, ESP also configured to do some tasks. So in the second part, what I'm doing is setting my Raspberry Pi to subscribe NodeMCU button. That is, whenever I'm pressing a NodeMCU user defined button, so it will be getting, the Raspberry Pi will be getting the message after getting that message, we can do some functions or whatever. We can do some task according to the task. That's what we can do with that thing. So let's get into the part 1. So part 1, what it means, installing. We need to install Mosquito server on Raspberry Pi, and we need to install MicroPython firmware on NodeMCU. So that the documentation are available. It's very easy also. Just go to the Mosquito and just go to the link and just go to the download. Then you can see below that so Raspberry Pi is there, Raspberry Pi. So then I will go to this link. So you can see that just update and just install this command. Whenever you type this command, automatically the Mosquito server is installed on your Raspberry Pi. Similarly for MicroPython, an easy access documentation is available. So by reading this documentation, you can easily install MicroPython, and you can even check the whether MicroPython is installed or not. So for installing that MicroPython firmware on ESP8266, and just go to the documentation and click that link. So actually the documentation is very easy. It is very through reading we can understandable also. So for that we need to just download that firmware. Just go to this MicroPython download page. I'm already open it on next tab. So we need to select our board, suitable firmware for our board. So my board is ESP8266, so I'm just downloading my suitable firmware. So after downloading the firmware also, we need to install. For installation, that's a tool is there, ESP tool. We just need to download this tool, and through this tool and selecting whichever port you are connecting. If you're using a Linux, means it mostly will be a dev/tty USB 0. If you're using a Windows operating system, it will be a communication port, COM4, COM5, etc. If you just find that COM port and just enter this command for erasing the flash memory, and this command for flashing that firmware. So after flashing the firmware, we need to get into the console of the ESP8266. So I'm using get into my PyPT. I already saved my configuration, so I'm just showing the configuration. I'm using Linux operating system. So my ESP8266 will be connected on the ESP0, and its baud rate is 1.5200. And if you want to check where you want to ensure which port you are connected, so just enter the message dms and correct TTY. So it's showing this CP210X converter now connected to DTY USB server. So it's confirmed that it is on DTY USB server. So we just get into that Python console. So yes, I'm just adding two numbers. So yeah, this Python is working, and the MicroPython is have inbuilt so many libraries here. So we can use so many that much libraries, and I think instead of that lower firmware that is inbuilt to the default firmware, I think that MicroPython is more flexible to program. And one more thing I just like on ESP8266 is that ES Explorer. So I'm just downloading that ES Explorer. So it's like a Explorer. Through this side you can program, and easily you can upload that program to ESP8266. Otherwise you need to just copy that code and paste it on Python console. That may be a time consuming. So this I found is very easy. So I'm just downloading that this link. So I already downloaded that file. So I'm just getting into that.
So this is my ESP2. So for running that,
so I'm just entering my the command. Just wait for a few seconds, it's getting on. So this is the window of ES Explorer. So in this, using this application, you can program either using your default firmware or using MicroPython. So for that I need to go to settings and will be going, and I'm just choosing which firmware I'm using. So I'm using MicroPython, then just it already selected. So in default it will be selected on NodeMCU. You need to switch to that MicroPython. And in the right side you can choose which communication port you want to connect. Just select a port and just select open. So it's showing communication with PMCU. So for communicate to this console, we need to press that reset button on the ESP8266. I'm pressing that, you can see that. So my Python console has reached. So in the left side I can program, and when I press the send to ESP, so automatically it loaded on this side. So I think it's very easy for program rather than that using PuTTY Python console. So we just installed that ES Explorer on PC. So let's start to code. So actually we want to implement MQTT protocol. So I'm using that. So first of all we need to connect to our internet, our ESP8266. For that I just made a function. Whenever we just want to connect, just calling a function, that's it enough. So I'm entering my SSID and password over there, and this is my program that automatically subscribes and publish data to the broker MQTTProtocol. So these all libraries are available in the MicroPython in itself, so you can easily access that things on documentation of the MicroPython. It's easier. So 2 GPU I'm using, LED. I'm using inbuilt LED that is connected on the GPU 2, and that flash button, it's available on NodeMCU, that's available on the GPU 0. So this function is connecting my Wi-Fi. I'm just through import, I can easily connect to Wi-Fi, and I'm just entering my server IP and watch all topic which I need to subscribe or publish. So this callback, whenever MQTT MQTT broker is sending some data. So whenever MQTT broker is sending some data, it's getting to this callback. So this callback is there. It according to the message, it do some task. Similarly, I made one user interrupt over there. So button interrupt. Whenever that user press that button, so it goes to this handler. So it handle alert. So it publish message on toggle. So that message is going to that Raspberry Pi. So the toggle message is getting on Raspberry Pi, so Raspberry Pi can do some task on the based on these messages. So for that I'm just copying my code and I'm just pasting it over my ES Explorer. So you can see this, my code is running. So now I am going to send it to ESP. So just press send to ESP. You can see that. Then you can see that it is connected to 192.168.1.9. Actually this IP, the Raspberry Pi is my 192.168.1.9. To verify that, actually I forgot to show you that Raspberry Pi IP address. So just get into the PuTTY, and I'm already saved my Raspberry Pi, so it's having 1.9 SSH I'm using. Just getting into my Raspberry Pi password, I'm just entering my password. So I'm just getting to my Raspberry Pi, so just verifying which my IP. So you can see that I'm using Wi-Fi and The IP of this Raspberry Pi is 1.9. So yes, I'm already connected to. This shows I'm connected to the broker. Second, you can see that it's waiting for message press. Sorry, button press. Sorry. So it's waiting for the button press. So in this code, what I made means the broker will send publish data on the topic on sample, and the ESP826 is publishing on data on test. So the broker, the Raspberry Pi, will send some message on sample topic. So according to that topic, it do this callback, and is according to the callback do this function, and it will publish a message on test. According to that topic, Raspberry Pi will do the some task. So for verifying that, I'm just taking my putty and I'm just sending a sample message. So the format is, you can use Linux console of the Pi for sending that, publish that data on MQTT. Mosquito underscore pub publish. That my -d, that means it's on debug mode, and -u, that's my username, -p, that's my password, and -t, that is which topic I want to publish, and I just want to publish on sample. Then only ESP know what task it should need to do. And -m, that means what the message I just want to send. So I'm just pressing over that. So here you can see that in ESP826 console, you can see that message is gone and it's on message. The message is, it's the topic and it's the message. So you can see that on NodeMCU the light is on. Similarly, for switch off that oh, so what I need to do means just get in my console and just instead of on, I'm just entering off. So my light has lit off. So still the console is running. It's waiting for its infinite loop. It's keep on waiting for the message, and similarly whenever the button is pressed, it will publish it. So it's waiting for the button press. So here what I'm going to do is I'm going to press that button. For that, here it will publish. The ESP826 will publish. So on Raspberry Pi, I need to subscribe for that. For that, I'm just taking putty and I'm subscribing. So that's a format: mosquito underscore sub, debug mode, username, password, and I'm subscribing on the topic test. So I'm just publishing on the same topic test. So just over there, and I'm just minimizing all that. So I'm just pressing my button, flash button. See, you can see that button press. I didn't enter that command on Raspberry Pi. Sorry. Okay, now this subscription is enabled on Raspberry Pi. Now I'm going to press the button. I'm pressing that button. So you can see that toggle message. It's keep on coming when I'm going to type it. So I think now ESP826 is configured on MQTT. To ensure that MQTT is working fine, in Linux, and one tool is available for MQTT client. So the MQTT.fx. So I'm just installing that application. So I already installed. So I'm just opening that. So I'm just connecting. I just want to connect to my broker. So I'm just entering whatever name you want to just enter, broker address, port number, and we have authentication also, we need to enter our authentication also. So I'm just connecting. So you can see that I connected. So I need to subscribe. So you can see that I'm publishing data on test. I can show you the code. Publication topic. The publication topic is test. So here in PC I'm subscribing that test topic. So my test is subscribe. I'm just pressing my button. See, message is coming out. Toggle. So I think it's working fine on ESP. So part 1 is almost complete because we set up ESP8266 on MQTT protocol. Next we need to move on Raspberry Pi. According to that message, Raspberry Pi have to do some functions. So guys, we just completed that part 1 demo. We just installed Mosquito server on Raspberry Pi, flashed MicroPython on ESP8266, and we just checked that MQTT protocol using a subscription and a publishing messages. So in the next section, that part 2, we'll be see on that how Raspberry Pi is managing or doing a specific task after getting a message from ESP8266. So guys, stay tuned with us. So in the next video I'm posting that part 2. So thank you for watching this video for part 1. See you on part 2.